Hi guys, this will be our last video on solving simultaneous equations. So today we will discuss method number 3, which is solving using the inverse matrix method. Okay, so once again, we're going to use the same pair of simultaneous equations. You'll see that in all our methods, our final solution is the same. Okay, so yeah, it's just a matter of choice which method you prefer. Okay, so using the inverse matrix method, okay, so maybe just let me put the name of the method that we're using down. Okay, so the inverse matrix method. What we're going to do is to first express this pair of simultaneous equations in the form of a matrix. Okay, so 3 will be here, and 1 will go here, 1 will go here, and -1 will go here. Okay, so let me just explain how I get this two matrices. Okay, so 3 times x, just recall how you do your multiplication for matrix. 3 times x plus 1 times y will give me the left hand side of equation number 1. Okay, and 1 times x plus -1 times y will give me the left hand side of equation number 2. Okay, so let us put the right hand side of equation number of the both equations into this matrix. Okay, and then I'm going to call this matrix matrix A. Okay, so just in case you've forgotten how to get the inverse of a matrix, okay, let us work it out very slowly. So the inverse of the matrix will be 1 over the determinant of the matrix. Okay, and then I'm going to, for this two entries, I'm going to sub their positions. So we will have sorry, I made a mistake here. We will have -1 and 3, and then for these two entries, we're going to add a negative sign to it. So we will have -1 and -1. Okay. So, on a side note, maybe we can calculate the determinant of A, which will be this times this minus this times this. So 3 -1 minus 1 times 1. Okay, and this will give me a -4. Okay, so over here we can work out A inverse. Okay, and from this calculation, okay, we can derive that x, y will be equivalent to A inverse 8, 4. Okay, so maybe just a side note, just in case you've forgotten how to do this. So let's say AB, matrix A times matrix B will give me a matrix C. To get matrix B, we will have to multiply A inverse on the left hand side of each matrix, and A inverse times A will give me an identity matrix, and therefore B is just A inverse C. Okay, so we're using this idea to help us solve for x and y. Okay, so A inverse will be positive 1/4, 1/4, 1/4, and -3/4 times 8, 4. Okay, and maybe I just shift this up a little bit. Okay, so 1/4 times 8 plus 1/4 times 4 will give me my first entry. So 1/4 times 8 gives me 2. 2 plus 1 will give me 3. Okay, and 1/4 times 8 will give me 2 plus -3/4 times 4, and that will give me a -1. Okay, so just by observation, x is 3 and y is -1. Okay, so let me just fill that in. So x is 3 and y is -1. Okay, comparatively, the inverse matrix method is a little bit more tedious in terms of calculation as compared to the previous two methods. So once again, it's your choice, okay, which method you prefer to use to solve the pair of simultaneous equation. Okay, so I hope this simple example helps in your understanding. Okay, so yeah, look out for our next few videos. I'll see you for now.